This video will talk you through how to complete the first page of the review packet. These first two problems are asking us to graph, and so when I graph an equation, the first thing I ask myself is what form is that equation in? So when I look at this guy, I have x minus 5 times x minus 3. I can see that I'm multiplying two x's, two linear factors together. None of them are being squared, so I know that this is intercept form. So I'm thinking to myself, if something is in intercept form, then in order to graph it, the very first thing I do is find the x-intercept. So I'm going to go down here and put a number 1, because that's the first thing I'm going to find is the x-intercepts. To find the x-intercepts, put a little 1 here, I let y equal 0, and then I can solve for x. When an equation like this is in intercept form, to solve, I use the zero product property. I set each factor equal to 0. So x minus 5 equal to 0 and x minus 3 equal to 0. And when I solve, I get x is equal to 5 and x is equal to 3. So my x-intercepts are 5, 0 and 3, 0. And then I can go plot those points, 3, 0 and 5, 0. My very next step is to find the axis of symmetry, because I know my ultimate goal is to find the vertex, but the vertex is on the axis of symmetry. When I know the x-intercepts, I know that the axis of symmetry will be right down the middle of them. So I could just look at the graph and see that we have x equals 1, 2, 3, 4 as the axis of symmetry. Or if I wanted to show some work, or if I couldn't really tell where it landed because maybe it's a decimal, then I could do the average of the x-intercepts. So if 3 and 5 are the x-intercepts, I can add them together, divide by 2. I get that that's 8 over 2 or 4. So that's another way I could find the axis of symmetry. And like we said, the whole reason to find the axis of symmetry was because it allows us to find the vertex. So I'm going to put a number 3 next to the vertex because that's the third step. I get that vertex by substituting the x value for the axis of symmetry into the equation. So y equals 4 minus 5 times 4 minus 3. And now I just simplify that using order of operations. So 4 minus 5 is a negative 1, 4 minus 3 is a positive 1, and when I multiply those together, I get negative 1. So my vertex will have an x-coordinate that is the same as the axis of symmetry, and a y-coordinate of negative 1. So 4, negative 1. Now, if I wanted to, yes, technically I could be done graphing, but that doesn't really give me a great shape for the parabola. So I would like to find some extra points. So one extra point that I could find, 4. I already found when x is 3, 4, and 5. Let's try 2. So I'm going to substitute x equals 2. So when x is equal to 2, I have 2 minus 5 times 2 minus 3. So that would be my negative 3 times negative 1, which is a positive 3. So I'm going to have the point 2, 3. So I go 2, 1, 2, 3, plot that point. Now the nice thing about this is because the parabola is symmetrical, I can reflect that point over the axis of symmetry and get another point. Excuse me. And if I wanted one more point, I could also try x equals 1. So y equals 1 minus 5 times 1 minus 3, or negative 4 times a negative 2, or a positive 8. So 1, 8 is another point. 1, 8, and again reflect that point over on the other side, and now I have a very nice idea of the shape of this parabola. Now it still asks us to do the y-intercept, so I'm going to put a number, maybe just a little asterisk here, and I'll show the work right here for that. The y-intercept, I remember that every y-intercept has an x-coordinate of 0, so that's just when I let x equal 0. So y equals 0 minus 5 times 0 minus 3, and then when I simplify that, negative 5 times negative 3, or a positive 15. So the y-intercept is 0, 15. The other things that it's asking me to do is the domain and range. The domain are all the possible x values, and because the graph goes forever to the left and forever to the right, I know that the domain is all real numbers. The range, well, that's my possible y values. Now it goes forever going up, but when it would go down, the lowest y value hits at that vertex, and the y value at the vertex is a negative 1. So all the y values could be at negative 1 or greater. So we have y is greater than or equal to negative 1. Finally, it asks us to identify the transformations. One thing that I have to consider is where the vertex is, and that will give me my translation. So I translated to the right 4 and down 1. So translate right 4 and down 1. I also have to consider whether the graph has been reflected or not. Well, it's opening up, so I know it was not reflected in the x-axis. If it was reflected in the x-axis, the parabola would be opening down, or I'd see a negative out front, so it's not reflected. And then I also have to consider whether there's a vertical stretch or shrink from the parent function. And because this a value is 1, that is the same as the parent function, so there is no vertical stretch or shrink. So my only transformations are translate right 4 and down 1. Going over here, it wants the equation in vertex form, and I know to write the equation in vertex form, that's y equals a times x minus h squared plus k. H and k come from my vertex. So my vertex I found up here, and my a value is the same, and we said before when we looked at this equation, a was 1. So y equals, I'm not going to write the 1 for a because we don't need to write it if it's just a 1, times x, that's a positive 4, we're going to see minus 4 squared. Keep the sign outside for k, minus 1. Now standard form, I can either take the vertex form or this intercept form and convert it to standard form by multiplying. I'm going to take the intercept form because I do think it's a little easier. That's how I prefer to do it. I will show you the other method as well. So I'm going to draw a little squiggly line here to show you my work for this. So I could take y equals x minus 5 times x minus 3. I'll show you using the FOIL method for the distributive property for this one, and then I'll show you using the error model for the other one. So if I used FOIL, I do my first x times x is x squared, my outer x times negative 3 is a negative 3x, my inner negative 5 times x is negative 5x, and my last negative 5 times a negative 3 is a positive 15, and we just carry that y equals down. Here I combine like terms, x squared minus 8x plus 15. That would be my standard form. So y equals x squared minus 8x plus 15. And then I could also take my vertex form. It works just the same. It's just a little bit more work here. Realize that when I square a binomial, it's really multiplying that binomial times itself. And now I'm going to use the area model for this guy right here over to the side. X minus 4, x minus 4. X times x is x squared. X times negative 4 is a negative 4x. Negative 4 times x is a negative 4x. Negative 4 times negative 4 is a positive 16. And if I combine those like terms, I'll get y equals x squared minus 8x for my negative 4x and negative 4x plus 16. However, I got to carry down that minus 1, which when I do that, 16 minus 1 gives me that 15. So I still get the same answer. So that is the first one, starting in intercept form and getting the rest of the information. Now, this next one, I see something being squared, and I don't see anything else. I just see one thing being squared. There's no other x's or anything like that. That tells me that this is in vertex form. And I know that if an equation is in vertex form, the very first thing I'm going to do is identify that vertex. I know that it's opposite the inside and keep the sign of the outside. So I'm going to plot that vertex right now. Negative 5, comma, negative 4. Now, I got to get the rest of the shape of the parabola. To do that, I'm going to make a table. Here's my x. Here's my y. In the middle of my table, I'm going to put my vertex, negative 5, comma, negative 4. I don't need to do any work in there. I already know the vertex. But then I'm going to go above and below, or to the left and to the right. So to the left would be negative 4, negative 3. To the right, oh, I'm sorry, no, it would be negative 6 and negative 7, and then negative 4 and negative 3. Now all I do is I substitute those x values into my equation. So we'll do negative 4 plus 5 squared minus 4. So negative 4 plus 5 is 1. 1 squared is 1. Negative 1 minus 4 gives me negative 5. And because our table is symmetrical, there should be a negative 5 up there. So I'll plot there. Because remember, our axis of symmetry goes right down the middle. We should be symmetrical about that. So now I'll substitute in negative 3. Well, negative 3 plus 5 is 2. 2 squared is 4. So we have a negative 4 minus 4. That gives us negative 8. Excuse me. Oh, I'm sorry, I plotted these other ones wrong. Those are not correct. Negative 5, those would be down here and down here. Negative 8 would be down here and down here. And there's my parabola here. So ignore those 2 points, those were mistakes. Alright, so the axis of symmetry would be x equals negative 5. My domain, again, is all real numbers. My range this time, because the y values go down forever, but they have a maximum, I have a limit at the very top. That highest y value is going to be negative 4. Everything else is going to be below it. So it's going to be y is less than or equal to negative 4. The x-intercepts, well, if you look at this graph, if the vertex is below the x-axis and the graph's opening down, there are no x-intercepts. The y-intercept, well, it's keep going down. It's going to be somewhere down here. To get the y-intercept, I remember that that's just letting x equals 0. So I will let x equals 0, and then we'll simplify and see what we get. If I use order of operations, again, 0 plus 5 is just 5. Then I do the exponents. 5 squared is 25, and I carry that negative down, and I get negative 29. So my y-intercept would be 0, negative 29. All right, over here, my transformations. Well, let's look at the translations. First, I went to the left 5 and down 4. So translate left 5 and down 4. I always got to check for a reflection, vertical stretch, or shrink as well. This time, because the graph is opening down or because there's a negative out front, I know that this is a reflection in the x-axis. And again, I always check that a value to see if there's a vertical stretch or shrink. I don't worry about the negative, but because the magnitude of that a value is 1, it is not vertically stretched or shrink from the parent function. So we are all set.